So this is a UPS which I have worked on previously. The batteries are due for replacement yet again. That only lasts a year. And this has got a big one, so it's like 700 watts or VA, what you want to call it. Bit vibrating, but the batteries are dead again. I can see that they're leaked again, so they just don't bloody last. So I've got an idea for an upgrade for this thing. I believe I've actually done a video on me replacing the battery on this unit once before, or a very similar unit, almost identical. So let's move this out of the way, and I'll show you the upgrade I had planned. Let's just get this out of the way. Now, as I'm sick of replacing those stupid little SLA batteries, I was going to do this. But then thinking, well, nah, I don't like that battery. I don't think it's good enough. So I had a rethink. So I thought I'll do this one instead. And actually, because it's 24 volts, I need two. So that's what's going to be using instead. So these batteries originally are rated at 130 amp hour, or I think it's on a 100-hour rate. I think something like, or about 100 amp hours on a 10-hour rate, something like a 20-hour rate. I don't know exactly how it works out now, but these used to be in the motorhome, and I've recently replaced batteries, so you can get an idea of the size of these things. There you go. There's the actual specs on the side right there. So yeah, that's what they are. So these are still usable. They're just not good enough for the motorhome. They can't handle that high current and stuff like that. So they're struggling a lot with the inverter, like the voltage dives. But they're still usable. They've still got a use. I actually have 4 of these, and I kept the 2 best ones and used as a supplemental batteries in the motorhome. And these are the 2 which are now unused. And they're basically at 60% health, right? So they can produce 655 amps CCA, right? And they're rated, I think they're rated 800 CCA. Might be on the side somewhere, but maybe not. Maybe somewhere else. But so they've still got capacity. They still produce currents. They're not bad, but so these are still perfectly usable as a UPS power supply. Considering the original batteries in the UPS, I think they are 12 amp hour, so these are 10 times bigger. More power, it's always good. So I'm going to be doing a modification to that UPS and running some wires out, hooking up to these batteries, and that will never have to be touched ever again, unless it blows up, of course. Alright, so I've taken the cover off, and you can probably see the white powder in there and cobwebs. It's been sitting in my garage for a little while. After the batteries failed last time, I put it aside one side, I couldn't bother with it. So you can see the battery there's leaked, and it's got the residues coming out of the battery. And I also noticed a couple of capacitors here bulging. These 2 caps have got bulges in them, so I need to do some replacements on this one, and just refurbish all that as well. So I'll take that board out, put new caps in, and change the wiring on these batteries. So obviously these batteries are going to be removed, which will make this thing a whole lot lighter. Although a lot of the weight is this transformer. It's got a massive transformer in there. So it's got these cables here which go to the batteries. And say these are in series, so they're 24 volts. And so yeah, all I've got to do is run a negative out from this side, that negative there, this positive here, extend those out in a couple of wires, run them through the bottom of the case or something, and run into the other batteries, and that'll be the end of that. But so I've got to do some work on this and refurbish these caps, just to recap on it. There's not that many in here. There's several small ones, but I'll just do a recap on it and bring all that back up to standard again. And I think it will be good after that. Okay, so I've got the batteries out, and yeah, it's bulgy. One's worse than the other. One's actually cracked, but this one's just got some slight bulges in it. I don't know if it's got any life left in it actually. Let's have a look. So this one here has completely had it. It's a crack right through it, and dead spiders and stuff. So it's fun. Yeah. but I suspect this one's also equally as dead, just hasn't exploded. So let's get the Siglent fired up and have a look and see if there's any power in it whatsoever. I'll be really surprised if there is. 1.5 volts, yeah, that's definitely had it. So no surprises there, and these aren't even that old. So yeah, so I mean these things, I'm really tired of replacing these batteries over and over and over again, because you know these aren't cheap. This is, I think these are about $70 each now. You know, and the last year, it's just ridiculous. The quality just isn't there anymore. You know, I should expect it to last a few years at least, but they just don't. So the crap. These are from JCar as well, JCar Electronics. Maybe it's a problem with the supply they have. Maybe they've got a bad quality product. Maybe that's the problem, but you know, I'm sick of it. So I'm gonna do a better way. You know, so I've got to pull this board here out and replace these caps. I don't even see it in there, but this one here and that one there's a bulging. This one's by far the worst, but I'll just replace them all. Have done with it. I've probably got all the ones in stock anyway, and I'll probably sit undo these screws, take probably this wire off, those two wires in. I think I'm going to just flip it over then. Work on it now. Here you can see a fan I put in, which is a little cooling fan. I don't even see it actually. Yeah, you can. Cool. Because to try and stop these batteries from dying, because it's right next to this transformer. It's actually right pushed up against the transformer, and part of my theory is that the transformer's getting hot, and that's going into the batteries and overheating the batteries. Right. So I put a little cooling fan here to help that, but that's no longer necessary. In fact, what I'll likely do, because it's got these massive batteries it's going to run it, this can run for a long time once I've got those other batteries on it. Instead of running for half an hour, it could potentially run for hours on end, which means these heat sinks probably aren't up to the job anymore either. Right, so I'm likely to actually put a cooling fan in the bottom here, across the transformer, to blow, you know, cold air onto the transformer to keep that cool. And I'll probably put some fans in the top here as well, somehow, maybe on the end or something. I'll figure something out. Maybe I put them on top of the case even, so they blow directly onto the heat sinks, to improve the cooling on those and to help that. Now there's an adjustment here, VR1 it's marked as. I believe that is the battery voltage. So I don't think there's any other adjustments on there. So once I've got these batteries set up and on there, I'll adjust this so it's just doing a nice trickle charge, because these will never need to have a massive high current charge going into them, because they're just going to last for so long. If you do power outage, it doesn't matter. This unit here can actually run my entire computer system, my computer, speakers, monitors, the whole lot. You can run the whole lot easily, but I stopped using it because I'm sick of the batteries dying. Right, so that's the reason behind that. So no, I'll do some work on this, get this all back up to standard as it should be, get it all working nicely again, and then I'll carry on with the upgrade. So I've had a look through my stock, and it turns out I've only got one of these capacitors, 1000 UF 63 volt, which is what these four here are. So those two are definitely gone. These two looks like they're still okay, but I've only got one. So I've had to order some more, so it might be a bit of a delay before I can finish this video, which is kind of annoying. And of course the upgrade, because I can't really do anything until I've recapped it. But I can do these other smaller caps, although these two here also, they're 250 volt caps. So I don't have any of those either, so I've ordered some of those too. But I can do all the other stuff, and I'll get this one in at least. But actually I might wait till new ones turn up and just do the whole lot instead of all exactly the same, in case it matters. But yeah, it's a bit disappointing, but we'll get there. Alright, so I'm going to replace these caps in here, and yeah, well, let's turn it on, that's good. So I was going to do the ones I can do, and I'll have to come back and finish the rest later on. So that's a 47 UF 50 volt right there. Let's get this thing out. Hopefully this is on camera. That's what's marked on the board anyway, 47 50 volt. Yeah. So I'm not going to bother testing, I'm just going to replace them. Now the problem I've got here is I've got 100 volts and 25 volts. So I'm going to have to put hundreds in, which are a bit bigger, but equally they're better. So I'm going to have to sort of, actually I better get the other iron going. And push the button because I've got so much stuff stacked in front of it. Right, so that's that one there. Another 47 just here, take this one out. Come on, come out. There we go. So I'm not going to bother testing, I'm just going to change them because I don't want to be revisiting this thing ever again. I just want to do it and have done with it, and then it's, you know, completed. Okay, let's put some other caps back in again. I don't even know if I need to be 100 volt caps, but that's what I've got, so here's another one. I'm pretty sure putting Nichicon caps in something like this is a bit of a overkill. Doesn't really require Nichicon, I think, but anyway. I only buy decent caps now, I don't buy rubbish ones. It's 47.25, cool. Got a whole bunch of those. That's a 35, I might save that one. 25. What's that down there? There's another 47 down there. Let's raise up there. Give it a shot. Another 50 volt one. So 35. It's no good. 100. It's another 47 there. I'm basing this on the board markings, but obviously as I'm pulling them out, I'm double checking that the value matches what's on the board, just in case there's a design change or something like that, you never know. And there's one more here. It's supposed to be a 10 UF, that one. UF 50 volt. Let's get a 10. $35 volt. 35 volt. 100 volt. 50 volt. Here's another one there. I'll use this other one here, it looks a bit crappier. Get the rubbish ones first. I do have some old stock of not so good parts, so I'm going to get rid of those as well. Still being better than the original ones, I expect. And I think this is that it. Oh no, there's one more down there. Can't see what it is. Let's get it out and find out. That is another 10 UF50 volt. Of course it is. Now put them away. Yeah, well, I think I'm going to chuck 100 in there. It's looking like the way to go. Yeah, I'll stick 100 in it. Oh no, I've got 63 there. No, mind you, it's an old one. Nah. 100 it is. Right. So I don't think there's any more I have to do, at least not with the parts I've got right now. And that's all I can do right now, so I need to wait for these caps to turn up and those two to turn up. Have I missed one? Oh no, it's not. Yes, I've got 6 caps still to replace, so it's a bit of a pain. Those two there are probably fine anyway, but what it is. I was thinking that the one I've done before on video, it was actually my dad's one. He's got one the same as this, and I've already recapped his one, which is why I've got one left over. I must have bought a pack of 5, so that's probably why I've only got one there. So anyway, I bought 10 this time. Right, so I've got it set up now so I can solder the leads on. So I've got a little flux pen here. I'm going to use this to apply a bit of flux to these. Just give it a chance to go, because some of these caps have been sitting around for a little while, so I just want to make sure they're all fluxed up quite nicely. I think that's all of them. All the ones for now at least. So let's get soldering. I've got my fan here running, so hopefully it's not too noisy between that and the air conditioning. Anyway. Bring this over slightly, it's not quite sucking up these fumes away. Hold on. I mean, ideally you have one of these fans venting to outside or somewhere else, but in my case I don't have that. I'll just have it running through filters, try and at least get rid of the worst of it. It's got carbon filters built into it, so I mean the smoke goes in but don't come back out the other side, so it's possibly doing something. Okay, See the close look at these, see if they look okay or not. Yeah, all look fine. So. And the board is actually surprisingly clean, so I'm not even too worried about cleaning it, to be honest. But oh, missed one. I'll just give it a bit of a clean. I think that's in. That's in anymore. Okay. One more there, I missed. Right, that'll do it. So that's all I'm going to do for now until I get those other parts turn up. So I shall carry on the video then. Okay, so actually just been into town with my wife. She wanted to go and get some stuff, so I popped in the JCars and got a few capacitors. Now these are Suntan brand caps, but they're 105 degree rated. Like, well, you know, at least I can fix this now and get the project done instead of waiting a couple of weeks for those other parts. I just want to get this out of the way and get it done with. So thought I'll just do that. Let's actually grab my tester, just over here. We'll have a look actually to see what these measure as. Series capacitance CSR. Hopefully you can see it on camera. Might just work, maybe. Maybe. Get a reflection off it. There you go. Alright, let's have a look and see what they measure as, eh? Well, you said 1 kilohertz though, so yeah. But low ESR is all good. Let's just change this frequency. 100 hertz. So yeah, 0.1 ohm, 119 UF. So it's actually slightly below spec, but yeah, you know, I'm not expecting too much from these caps, as long as they're kind of okay. So they are JCar caps. They're just some, you know, who knows what where these are made. They're all slightly below spec, but you know, if I change frequency again, let's just see what else we get. Yeah, can't measure those frequencies, it's fine. Try 120 hertz. Yeah, so it's fine. You know, they're new, so they should be, you know, adequate. They're going to be better than what's already in now, so I'm sure of that. So, right, let's pull these other ones out. I've already got it ready to go. I've got the iron warmed up. Let's start pulling these things out. Could be little wires, quite a lot of metal here. Big ground planes and surface areas. Okay, there's one. I'll measure these afterwards and see how they actually test. Come on, melt it. Just one of the bulgy ones. Next one is over here. That's the other bulgy one. And there's one more over here. I think I've got it in my place. I believe I have. Right. Actually, I want to test all these now while I'm thinking about it, otherwise I might forget. Let's see what we find from the original ones. Maybe this set up so it doesn't slide out of the way. So this is a non-bulged one. So visually it looks okay. That one still measures okay. Capacitance is slightly down, but might just have 1 kilohertz. Let's go back to 100 hertz, shall we? Measure it again. So yeah, it's as good as a J-card one basically. Next one. So the ESR is slightly up, and that's a bulged one. Slightly bulged, and the ESR is only up by to 0.5 ohm. So it's not a big change. There you go. This one's really bad. This is a really bulged one. So 5 PF, 83 mega ohms. I think that's definitely had it. And the next one. This one visually looks okay, but it's not measuring very well. Yeah, this is also gone, but it looks fine. It's not bulged. So go figure. So yeah, 2 of those 4 caps definitely needed doing. One's on the way out, one's okay. So that's pretty much what I expected. Thought I was going to replace the whole lot. So anyway, I put these ones in and we'll camera. Okay, so I've got the new caps in place. Let's solder them in if I can find a solder. Right. This might take a bit of heat on some of these because of the ground plane. Just push that one down slightly to make sure it's against the board. See it moving around a little bit, so I thought I'd better just redo that. Okay. So that should be all good. Let's cut these legs off. I always keep these because they're handy for making jumpers and stuff like that, and artificial pins when you need things. Always kind of handy to have a little plastic box that I put them all into. Don't keep all of them, but they certainly do come in handy. I do have a big clear out sometimes. I do actually have a bunch of them on my desk for a while and just shoved them in the bin. It's like, oh, had enough. Too many getting in the way. So, right. So that's those in. Let's give us a bit of a clean up. then that should actually mean the power supply is fixed. Should mean it's fixed. I've only got 2 capacitors I haven't replaced because I haven't got them in stock. They're 250 volt caps, so they're a bit of a pain. I've ordered some, so once they arrive I'll replace them then, but I think that, visually they look fine right now anyway, but I think these ones go because they're right next to the heat sinks and they're the main smoothing caps for the AC side of things. So, oh, that's not supposed to happen. Tube came out. Yes. Hopefully the weather stays reasonable today. It's got a storm coming through and I'm in a flood zone, so as long as it doesn't get too bad it should be good, but have to just keep an eye on things, make sure it's not getting too bad. There's one over here I might have forgotten to clean before. Just there. Is there one? No, that's right. Okay. So the idea of this is that when we do get these big weather events, is that I've got a big power supply to keep my internet going because I use wireless internet. So if I need to keep my wireless network running, all that sort of stuff has to keep on working. So this will be running all of that. I've got a few UPS already running it all, but those batteries are starting to fail on one of them. I'd think, well, I'd rather just spend $20 fixing this than $100 on batteries for that UPS, and the other one's going to go in 6 months time, so it's going to be another $100. So I'll just get this one going and use those big batteries. It's just simple. So one of the other things I've done is I've put this fan here in. It's not a great mounting. It's got these screw positions on this heatsink here, so I've used that to screw it down just long enough. So this is actually blowing directly across those 2 heatsinks there, and it's obviously going to cause some airflow across the front of this one. It's just blowing across. So I put a couple of header pins on the bottom of this board under there, so I'll just plug it in to there. So I mean, the fans never last forever, so at least I'm just plugging another fan in when the time comes. I was thinking about putting the one down on the power supply, on the transformer down there. I might just see how that goes. It may be okay. Anyway, now it's got this airspace around it, because it does have all ventilation holes right through on the casing and then on the top. So it might be enough convection anyway. We'll see. If I do need to stick one, I've got plenty of space to put a fan right there in front of it. That'll suck air through the front ventilation holes, blow out the back one. So if I need to do that, I can. I'm just worried about overloading this regulator, because this is a 12 volt regulator, 7812. And that's what this fan is currently running off. Now this fan draws 160 milliamps. I'm not actually sure what the current loading is on that device. The fan I did have here, down here, blown across the transformer originally, that draws about 120, I think it was. So, and that seemed fine with that, but I wanted a bigger fan to try and get more airflow across a larger area. So anyway, I'm going to bolt this back in again, and then I'll look at how I do the wiring to the other batteries. Now I believe this wire here is the charge circuit. That plugs into here. It says P1 battery plus. Alright, that also goes onto the transformer on the back, which goes onto the big thick wire, which goes to the main battery and onto the transformer itself. So I think they're joined together there. So I think this is actually the low voltage or low current circuit to the unit here, because it actually traces through to the front panel, goes through this connector here to the ribbon. So it goes to the switch button, press button switch. Right, so it then powers it from the battery if you try and push it on without any power, to enable the turn on circuitry. But this has got some diode regulators down here. That's what these caps are doing. They're regulating the AC back to this line. So I'm not actually convinced that there's a little VR down there, which I pointed out before. I'm not convinced that actually does adjust the battery voltage. It may not be possible, because it's got 27 volt taps off this transformer down here. They come up and go to this point, and it goes through diodes, and it's got these smoothing caps, and then it goes out this line here. So I'm tracing the circuitry out, trying to figure out how to adjust the charging voltage. So if I need to adjust it, what I'll do is I'll clamp onto this cable and measure the current going through this cable, and if it's not too high a current, I could probably just chucking a serious diode or something in there to drop the voltage a little bit. You know, maybe a 10 amp diode or something I could chuck on it, and just to reduce it so it's not over. Those batteries won't do much. I mean, they'll last for hours and hours. So I want to make sure I've got a trickle charge going on. It doesn't have to recharge quickly when it comes back on again. That won't be an issue. So it needs to just trickle charge. So I don't want too high current or too high voltage coming out of this circuit. So I'm going to have to look at what I'll do with that once I've got it all powered up and running. I'm pretty sure that VI doesn't adjust it. It might be the mains voltage it adjusts. So I'll find out once I power it up and get it hooked up. Then I'll play with that pot and see what it does. Whether it's adjusting the AC voltage, whether it's adjusting the battery charge voltage, I'm not sure. I suspect it's probably the AC it adjusts. But okay, so let's get the thing bolted back together. I won't bore you with that part, and I'll carry on. Okay, so now I've got to try and crimp these cables onto this, well, these terminals onto this cable. Now, you need a decent tool for this. So you kind of need something like this, right? When you got to these big terminals like this. I mean, these are small ones. I could probably do those with a hand crimp reality, but I've got this. So we shall use it, and I shall just get myself set up. I've already done one already, but we'll see how we go if we're doing it on camera. It's not going to be easy. So let's get the terminal in and get it the way up I want it. I want it this way up. It's a bit hard trying to hold it at the same time. Once I get the thing held, I can let go of it. Right. Hopefully it's on camera. I'm not doing a very good job of this, I'm pretty sure. Anyway, so here we go. Right. Crimped. Yeah, that's alright. It's not pulling off. So that's good enough. So these go on the actual battery terminals. I'm just going to run this twin core up. This is 8 gauge cable, and I probably won't use the whole length, and I'll just run it through one of these holes in the bottom of the chassis, and make sure there's no sharp edges on it, and run it up through the bottom of that, and then join onto these, which are supposed to be, these are 10 gauge cables. These are actually smaller. But no harm in having a bit bigger, is there? Now, the tricky bit I've got here is actually splicing onto these cables, because I kind of want to keep it intact as well. So I want to put the batteries back in again, maybe one day, maybe, but it's not likely. So I'm just sort of a bit torn between cutting those connectors off and splicing onto them, or using a connector to go onto it, but the connectors aren't very strong. I'll get one out. These are what I have, and they're not particularly thick. Alright, so I don't know what their current capacity actually is, whether they can handle enough current. I mean, they go in okay, but then I'm not, there you go, it's the inside of it. It's not particularly chunky, so I don't really trust these for this particular application. I think they're not really meaty enough, so I'm looking at probably cutting those off and splicing wires straight on. I probably have something to do that particular job, I expect. I'll have to have a look and see how we go, but that's the plan. Okay, so I've got the power cable spliced on, running down to the batteries, which are all hooked together, ready to go. Now I've got my little clamp meter here on this cable here, which I believe is a charging cable. Alright, so if I hold the button down, alright, so that's what it's actually running through the electronic circuitry, about 200 milliamps or so. Alright, I haven't got any power going to the actual UPS yet. So it's about 200 milliamps to run the electronics through that cable. Let's have a look through the other cable and see what we actually get through that one. Get it so you can see it, hopefully. We'll wedge it around. See that? Not really. Come on. There's always a way of wedging something. There has to be a way. Right, you can read that? Yep, great. So, let's zero that again. Get rid of any stray stuff. Let's see what happens when it's actually running the transformer. So that's at 1.5 amps. Okay, so it's at 1.5 amps to run the transformer. With no load on, obviously. So let's take this back out of the way. I'm going to stick this back on here. And re-zero again. Let's plug it in, see how much charging current we get. Right. Let's plug it in. Let's turn it on. So there we go, 700 milliamps charging current. So that's not too bad. Can live with that. Question is, what's the voltage? Let's have a look. Let's get my meter fired up. A little unprepared here. I might spin this back slightly. Try and get both in shot. 60 volts. Okay, so let's measure it right there. 26.1 volts, 26.2, slightly declining obviously because it's charging. Okay, so that's 13.1 volts, which is okay. We'll have to see what it's actually doing once it's fully charged, the batteries up. But 13.1 volts doesn't seem at all bad. Of course, it's only 600 milliamps current, but you know, it's fine. So that is at least working. It reckons the batteries are fully charged. Of course it does. So yeah, that is at least working. I'll have to let these batteries charge up, I think, and then retest that voltage and see what it's sitting at. I suppose I could try playing with that dial there and see if it does actually change that voltage or not. Let's just spin this, shut it down, kill the power. Because these heat sinks here, I think they're live, so you know, it's one of those things you don't touch because they're coming from that transformer. I think it's only plus or minus 15 volts though. You know, so I think it's probably not too bad, but you know, just be careful anyway. This is a ground. I know that for a fact. This is a ground connection. So let's just spin this out of the way so we can get to that adjustment and get a screwdriver, which I can use on that. Yeah, that one right there will do. Let's fire it back up again, and we'll see if I can get a different voltage. Just want to see if this adjustment actually does anything or not. Doesn't seem to be. No, it's not. So I'm not quite sure what that's doing. It might be on the AC side of things, which is adjusting. So let's have a look at that. And probe in there. And try not to zap myself at the same time. Let's find some terminals. Ignore the noise, it's just the fan touching the heatsink. Bring it around a bit. Now I think those are the AC terminals just there. There and there. Hopefully I'm right. Yep, 230. See if it's just anything there either. Yeah, it's adjusting the voltage very slightly, I think. Maybe, I don't know. I'll just leave it in the middle. It's not adjusting very much at all, so maybe it's not there. It could be adjusting battery. There's nothing obvious. It could even be a set point for the battery voltage before it shuts off or something. I don't know. If anybody does know what it does, it'd be quite nice to find out. I have an idea for testing the voltage that this will charge at. It's got almost a loading on it, right? So I know that right now it's now down to 400 milliamps charging current. We're getting 26.8 volts. Alright, so it's gradually creeping up. So I want to know what its maximum voltage is going to be sure that these batteries aren't going to overcharge. Now each battery can be between 13.6 to 13.8 volts in its standby float charge system, right? So this is how this is going to run. So that's 27.6 volts max, down to 27.2 volts. So it's got to be in that range from 27.2 and 27.6 in order to be in its ideal specified voltage for these batteries, as the stated by the manufacturer. So what I'm going to do, I'm going to open circuit this and see what the voltage goes up to. So it's a little bit tricky, it's a bit awkward. I've got to stick a probe in there. I think I can wedge it, can I? Maybe I can wedge it, it may be helpful. No, ain't going to work. Maybe. No, it ain't going to work. So I'll figure out something. So I'm going to disconnect this battery here. If you watch that meter up there, obviously this current will drop and I've got it disconnected. And then I'll stick the probe across the battery terminal and see what we get. So, you know, charging current is zeroed now. So zero there. There you go. Right. So that's on that terminal, and stick it on the negative. Doesn't quite reach the actual battery terminal, so it's 27.4, which is perfect. That's smack bang in the middle. So that's great. That's exactly what I want it to be. So that voltage is absolutely perfect for these batteries. So I'm happy with that. So I can actually put the thing back together and obviously run those cables through the bottom there, through the case, and put it under my desk and hook it all up. So all done. No more worries about batteries failing every year. Here's the batteries. Catch you later. Give us a thumbs up and subscribe and click the bell icon to get notifications and all that kind of stuff.